Good evening. Welcome to the DuPage Valley Observatory of the Naperville Astronomical Association. We are broadcasting our imaging to you tonight, like we've done a few other occasions. We're starting out with a kind of a blue flickery looking screen in front of you here. With the first object of the evening. We've been, of course, doing our technical difficulties things of trying to get multiple telescopes going in multiple places, but we'll do our best to present you a number of different objects this evening, one way or another. As a general introduction, if you haven't been to our virtual star parties before, like we're doing tonight, you're either watching us on Facebook or with the stream embedded on our club website page. Feel free, if you have any during the evening, any questions or comments, to put them into the comments section on Facebook or on the club website page. If you're viewing from there, you can send us an email and at questions@naperastro.org, and we will, our control room person, Jim, will try to pass those along or answer them himself, because Jim knows a lot of this astronomy stuff too. As a brief introduction, we have two observatories here at our Astronomy Education Center. We have our visual telescope in the other building, but we're in the building with the video setup. So what you're looking at tonight is the monitor for that setup. And on the monitor is a live TV camera view being taken through the telescope. This is the kind of thing we're going to be sharing with you tonight. This first object in live view, I can prove it's a live view by putting my hand here and pointing things out. This first object is called a globular star cluster. Our galaxy has hundreds of billions of stars in it, and they're mostly in a large flat disk. So if you looked at it from above, it looks like you're looking down on a pizza with a big spiral in it. Or if you looked at it from the edge, you'd be seeing a very thin line because it's a fairly thin disk. So most of the stars in the galaxy are in that disk. But there are these star clusters called globular star clusters that are actually floating in a sphere around that disk of the galaxy. They're very old. They formed while the galaxy itself was just first forming. So some of these stars in a cluster like this are almost as old as our universe itself. So some of the stars are getting over 13 billion years, close to 14 billion years old in a cluster like this. So these clusters formed before our galaxy actually collapsed and flattened down into a spinning disk. Interesting things about this cluster. It's called, we call it M13. It's on a list of objects called the Messier list. So they get, we abbreviate that to M numbers, and it's number 13 on that list. It also has another more proper scientific number of NGC. Let's see, this is 6205. And so those are, that's how you would look it up if you were an astronomer in the catalog. It's in the constellation of Hercules, which if you go outside right now and it's clear where you are, Hercules is almost overhead. So we're looking fairly straight up. Hercules is, of course, the hero. Heracles in Greek, Hercules in Roman naming. This cluster of stars has hundreds of thousands of stars in it. It's at least 300,000, maybe close to 500,000 stars in it. We're only seeing the outer brighter ones here in that bunch, but there are a lot there. This object is about 22,000 light years away from us. So this light that is shining into our telescope, oops, the telescope just jiggled a little bit in the breeze probably. So that little blurring that proves it's live, it'll stabilize now in a moment. The light that's shining into the telescope has been traveling over the galaxy and toward us for 22,000 years to be caught by the TV camera in the galaxy. If you were out here tonight, we could be showing you this through our visual telescope. It does not look this bright, and you don't see quite so many brilliant stars in it, but it does look like a little pile of of little points of light, of little diamonds, like in the sky, looking through it at a regular telescope. You can actually see it. If you know where to look, you can see it in binoculars as a tiny little fuzzy spot in the sky. But even in a fairly small telescope, it's an interesting object to look for. So it actually wasn't the first object on our list tonight, but we're rearranging things a little bit by the brightness of the sky. Jim, is Frank ready yet with anything, or?
No, he's having a little bit of trouble right now.
Okay, we have another one of our members. Frank is in his observatory in his backyard, and we were going to be switching off, but he's fighting with equipment like we oftentimes spend time doing. So I think I'm looking up in the sky here over me now to decide what the next thing we should look at just by how dark the sky is. Yet I think we'll go to a different.
Drew, hold on one second. I think Frank's trying to chime in. Let me unmute him.
Okay.
Frank, if you click the unmute button. Maybe not. Go ahead with what you're doing, Drew.
Oh, okay. So what I was going to point out next is that I actually need to get a chart so I can get there rapidly. But the early summer sky that we're in right now, if you were at our last session out here, which is more under the spring sky, there were a lot of galaxies, and I was telling you about that, how during the year we see different.
Drew, we do have Frank.
Okay.
Frank coming through with his image.
Okay.
I'll flip.
This is M5.
Okay, hold on, Frank.
Can you hear me?
Yeah, we can hear you.
Okay, it's M5.
So if you can still hear me, M5 is another globular star cluster. So Frank, I don't know if you wanted to tell a little bit more about it, or if you want me to keep on talking, or
Well, you have the script there. I'll be working, trying to make sure things don't fall apart here. So,
so M5 is another globular cluster. We were just looking at M13. M5 is a little bit farther away, not much. These distances are kind of approximate because we don't know really precisely, but M13, I said, was about 22,000 light years away. M5 is about 24 or 25,000 light years away. So it does look a little bit smaller in the sky, but the main reason this looks smaller on your screen, where you're viewing it now, is Frank's telescope setup. So how big things look on the screen depends on both your telescope, the focal length, or how long the light processing part of the telescope is, and the size of the imager you have, the size of your camera chip, basically. And Frank is using a very more professional camera. We're using a TV camera, and he's using an imaging camera. So his camera sees a much wider area. It's a bigger chip. So that's why M5 pretty much looks smaller on the view you're seeing here from Frank's telescope. It's not that it's that much smaller, or that it's even that much smaller in the sky, but it's just the difference in imaging. But M5 is in the constellation of Serpens, this serpent. It's a little bit smaller globular cluster. It's certainly got over 100,000 stars in it, though.
Wait. Yes, I will. Hold on.
Okay. We can hear you, Frank.
Sorry about that. I forgot about those.
I have to shut off the red crosshair there.
Okay. That's all right. We didn't mind the red cross. Okay. Anyway, again, we're looking at really old stars. A lot of these stars that you see, those little points on the screen, are like 13 billion years old or more. The cluster itself for us to, for things, something that far away to look this big in the sky and not just look like a little point, it has to be pretty big. This cluster of stars is about 165 light years across. So that's quite large. Some of the stars around the field are also stars that are closer to us in the galaxy that we're looking through. Frank, if you want to tell him a little bit about your telescope, you could do that. I'm going to move this telescope to the next object while you're talking, and I'll be confused if I.
What I will do, I hooked up the dome cam again, and I will see if I will turn that on, and let's see if we can actually see. Hold on. Okay, I will turn on the dome cam. And there is the telescope we're using. What I'm using tonight, the camera, you see several cameras. It's this one, it's the lower of the two red cameras there. And that is an Otic Infinity camera, which is a video camera. It's attached to my 10-inch Ritchie Chrétien astrograph. Above it is my 132 millimeter refractor. Everything is mounted on my Paramount MX mount there. It's inside my dome. My observatory is located in the extreme northwestern Plainfield. In fact, I'm right like 200 feet from the border of Plainfield and Oswego, Illinois. And we have been here for about a year. I used to be in Downers Grove, but when I built my new house, I figured, well, let's put the dome right next to the house. So I'm sitting in the control room of the observatory, so I don't have to go outside on winter nights. I can sit here in my nice, not heated, but at least warmer than the dome, that's for sure. So anyway, that's the equipment we're using tonight. The other camera is my main camera, which has all kinds of filters on. I do most of my work in monochromatic imaging, black and white, with narrowband filters. And in fact, I can actually, Drew, if you don't mind, I'll show them some of the images. I think I may have some pictures here. Do I have any pictures? No, I probably lost them. Nope, that's all right. We'll just go back to the webcam here and me. And let's go to your next image if you have it. Otherwise, I'll go back to our...
I'm still working on just moving up to
Still working? Okay.
another object.
Another object. Okay, well then I'll go to the desktop again. And we're still at M5. We can swing. Let me turn off the light in the observatory for the dome cam and turn that off. And we can swing. People might think, are we really live? Yes, because I'll actually swing to another object. I believe the next thing you wanted, well, here, you're going to go to M13. The Planetary Nebula you wanted in Draco, that's going to take a while to really. Oh, how about well, we can do M27 next. Shall we do that, Drew?
Whatever you like, Frank. That's
okay.
Up to you.
All right, hold on. All right. I will stop this image. This image has been building slowly. You notice it's getting a little denser. We're getting a little more fuzz around the globular here. This has been a total of a 460-second exposure so far. What happens in this particular camera, I think yours probably does the same thing, or does it? Does it stack the images, Drew?
No, this is, the control with this camera is simply to slow down the video chip. So it is sending a slower image, basically.
Okay. Well, you may have noticed now that the image is actually it suddenly got bigger, you might say, because I've been taking 4-second exposures over the last 460 seconds. This is a total of 115 exposures, stacked over 460 seconds. So this is comparable for those of you who are familiar with Registax, the program created by this Dutch amateur. If you stack numerous individual exposures together, you will get better resolution. And so this is what this does automatically. And it even, in fact, if you have small errors in tracking, although I don't have too much problem with that, but it'll actually correct that as well. Okay, I have stopped the exposure, but the buffer will keep the image while I move on to the next image. So I am going to go here. We're going to try this is M27. So we will find M here. We'll go M, target object. Find M27. Find. Execute. Yes. Now it's going to do a meridian flip. So I'm going to have to make sure we're centered, but we should be. I don't know if you can hear it whirring around in the background there. And I'll have to move the dome, obviously, too. I'll just leave M5 on the screen there.
I don't know why the screen is black. All the way up.
Okay, we'll see if anybody is home here. I will now switch to let's clear this. Let's see, hold on. We're gonna clear. Image quality, where's our fast saturation brightness, binning at 0, Venus peak, max peak. Come on. Okay, and now, where are we? Not nearby. Okay, let me just check.
Canvas turned all the way up. Let's go to start.
Okay. It's there, but it's sort of faint. Let me move things around and see where we are. The only problem with, what's the field of view of your camera, Drew? Because mine, of course, is very tiny.
The camera in the sky is about 1/4 degree across.
Yeah, see, I have about, I think about 12 arc minutes, which makes it a little difficult to,
I don't know how to put this camera.
are you seeing our movement here? Yes, yeah. Okay, let's see. Here's those 3 bright stars. Okay, come on, where are you? Oh,
A Facebook question that
you guys got something?
no, Drew's still going for something too, but we have a Facebook question wondering, and this is kind of a open-ended question, but is there any areas you guys know of where it might be possible to see that comet?
Well, I saw the other day. I mean, it's easily seen. It's northeast, about 10 degrees high, at about 4:30 in the morning, directly below Capella. It's about halfway, well, about a third of the way up from the sky. If you can find Capella, go straight down about 10 degrees high. It's pretty obvious, actually.
You just have to have a real
Binoculars, no problem.
but you got to have a northeast
View, yeah.
point of view that's very low to the horizon.
Right.
Low to the horizon with as few lights in the way too for the pre-dawn stuff. But of course, it's the sunrise that will be making it harder to see too. But it's mainly to be able to see close to the low horizon in the northeast in the sky. So wherever you can do that locally is good. So we're having issues with the camera on this of getting it to do a decent exposure. Not sure what's up with the revolution. It's not responding to us. We might swap out cameras here.
I see where it is. Okay. Fine. Now I know where it is in the field. I can move accordingly. It's that away. Nope, not that away, that away.
It'd be way brighter than that. Shouldn't be glaringly.
And let's try here. Come on. There we go. Now,
I think I better swap cameras.
it's below these two stars.
Okay.
In all the chaos tonight, I was not able to really align the scope as well as I'd like to, and because normally I'm within about, oh, there it is, isn't that it? There, yeah, that looks vaguely familiar. Yep, there it is. Okay, let's move over to here. All right. I'm pretty sure we have it here. Let's move that down. Okay. Now, I am going to stop the search mode and go into exposure mode. I'm going to take a 10-second exposure. Executing. Let's enlarge the field a bit. Aha! I'm going to stop that. Well, no, I'll just leave it. That's right, I can't. Let's stack, yeah, where's the. Are we getting that, guys?
Yeah, I can see it.
It'll be, again, it'll burn in over the next, I'm using 10-second exposures. Close the door, keep the mosquitoes out of here. I have max peak. Now I can adjust this. I'll show you what it looks like in medium. It'll get brighter, but you get grain, you see? And I don't like grain. That's even worse. But and full range, that doesn't show you anything. I like, this is my favorite is what is called max peak. No, not max peak. I mean the mean height, mean HD. Yeah. Let's try medium. Medium. Okay, we'll leave it at medium. A little grainy, but that's okay. So far we have 12 images, 120 seconds. Here's the 13th image. Usually after about 2 minutes, from most things, it reaches, maximum. You don't get a lot more. Image quality, I'm gonna blend pixels here. Yeah, okay.
Basically, this is just taking a bunch of 10-second images and stacking them on top of each other.
Right.
To a higher quality.
Yeah. Now, so I'm using, what they call medium, low. You lose some of the grain, but to get a sharper image. All of these come out as JPEG images, so you can save them. You could work them in Photoshop if you want to increase the contrast and what have you. Generally speaking, in any exposure longer than 15 seconds, you start getting, the sky fog starts coming in too. And it depends on good. Now tonight, transparency is pretty good, but I am aiming I'm aiming northeast here a bit, right over my neighbor's house. And my neighbor has a swimming pool and the lights are on now and there are people swimming in it. And so we're getting some, shall we say, sky glow. Now, Drew, look, you have a very bright star there. What is that?
I have Drew on mute right now. He's still, I think he swapped cameras and he's trying to, I think he's trying to find the Ring Nebula right now.
Now, you mentioned that, you didn't like to show open clusters because the camera just sort of shows, fly specks in a black field. We can try with this. This does pretty well with clusters. And I see, I'm looking at my SkyX chart. M39 in Cygnus is right next door here. We might give that a shot and see what. Although, wait, I'm using not with this scope. I'd have to go to the refractor again. Wide field works better with clusters, obviously. But we could change. We could change the scopes.
Let's see. Let's give Drew just a minute. Oh, yeah. I see Drew's got the ring starting to come in view.
Okay.
So once we flip to Drew, you'll have a few minutes that you can.
Okay. Yeah, let's switch to the wide field because this is fine for what we're looking at here, but for clusters.
Yeah. All right. I'm gonna flip over to Drew's view.
Okay.
And we've unmuted here, Jim.
Yeah, so I was having trouble with our color camera. So I am put in the black and white camera and I am making things blur because I'm centering an object, which should stabilize now.
That looks
At least we got an object. I don't know. Sorry, we never know when there's going to be technical glitches, but that our color camera was not behaving well this evening. Different kind of object. So we were just looking at star clusters originally, and then we switched to the object that Frank was looking at. which is called a Planetary Nebula.
We had a Facebook question asking if you can tell us
Okay.
anything about that, the size or the distance away or any.
Okay, I will do that. So Frank was looking at, I think that was, I was kind of busy here. He had M27 in, didn't he?
Yes.
I'm going to flip out to Frank's M27 real quick while you talk about it.
Okay.
It's still there, yeah.
All right. So actually, that object and the one that you'll see that I was just showing are basically the same things. They're gas clouds around dying stars. When a really big star, say a star that's 10 times or 100 times as big as the sun, runs out of fuel in its core, runs out of the hydrogen that's fusing in its core to be its energy source. In the end, when it runs out of everything down there to burn, it can actually explode and become what we call a supernova. But most stars aren't that big. Most stars are more around the size of our sun or smaller. And when they run out of fuel, they don't explode, but they go through a very irregular stage of where they'll puff up and they'll shrink down, and they'll do that several times, but they'll tend to blow off some of their outer gas, some of their outer shells of gas out into space around them. The main mass of the star, the core of the star, then shrinks down and becomes what's called a white dwarf. It's actually, the furnace has gone out inside of it, but they become very hot from compression, from just the crushing of gravity of all the material of the star that heats it up a lot. So that colorful gas cloud that Frank showed, which is on your screen now, is that gas cloud exploding out into space, spreading out into space. M27, I wrote some notes down, I'll bet I have it here somewhere, is about 1,200 light years away from us. Oh, it's in the constellation of Vulpecula. The central star is still visible in the middle of it there. It's very hot, and this radiation from that star is actually, the star is so hot, it's mainly in ultraviolet, and it makes that gas that it blew off into space glow. So that's the nebula that we see. That little star in the middle, which actually you can see in Frank's view. I can't point it out for you, but it's kind of in the center. If you sort of draw an X, there you go. That's it. That's it right there. That's it right there.
Wait. It's back. There we go.
Yeah, that's it. So that's this what that we measure star brightness in what we call magnitudes. That's a 13.5 magnitude star. Its mass, the mass of that star, is a little more than half of the mass of our sun. It's about 0.56 solar masses, because the star probably was closer to the mass of our sun when it was still a normal star, but it blew off its outer shells in space. But that star is a little smaller than the Earth, so it is crushed down so much. Eventually, staying within 10,000 years or so, the gas will have dissipated out into space, and the star will be cooling down and not giving off so much energy, so we wouldn't see the nebula here anymore. If you want to switch to back to our view from here, Jim, if you can do that, guess you can handle the spotlight. There we go. So this is called the Ring Nebula. It's another planetary nebula. This one, the shell of gas expanding around the star, ends up looking like a donut to us. It's actually probably more like the shape of an hourglass, and we're looking sort of down, right straight down on it. So we see it more as a cylinder or as a donut, but it's actually extending towards us and away from us. You can see the central star in the middle of the donut there. That star is, let's see, I've got notes on this object here somewhere too. There we go. That star is actually fainter than the one in M27 that Frank had. It's about 14.8 magnitude. This object is about 3,000 light years away, a little farther away. Actually, about twice as far away as the dumbbell M27 was, which is one of the reasons why it looks smaller in the sky to us. The the disk of this, from our point of view here in space, is actually about a light year across. So this is an immense donut of gas. The white dwarf, like I say, in the center is about 14.8 magnitude. The surface temperature of that little star in the center there is over 200,000 degrees Fahrenheit. The surface temperature of our sun is only about 10,000 degrees Fahrenheit. So this one is immensely hot, and it's just from being crushed by gravity that it's heated up that much. Other notes I had about this. Oh yeah, there's a second star actually in the middle. If you see the little star right in the center, just up from it towards 11 o'clock or 10 o'clock there's another little star. For those of you who are real nerdy, that star is actually below 16th magnitude. So it's amazing what we can do with a live video telescope view from this rather light fluted skies of Naperville. That's one of the reasons we put this system in. What I wanted to see also was there's a galaxy in this field of view, which I have seen out here, but we're not picking it up. Right, I'm going to increase the brightness just a little bit. This view, it'll click up in a second. No, there's a barred spiral galaxy that's actually in this field of view that, again, I have seen here before, but I'm not picking it out. But, so were there, did I answer the question, Jim?
Yes, yes, you did.
Okay. Okay. Yeah, I hope to show you this in color. This is a black and white camera. It actually has a little better resolution than the color camera, but the color camera just did not want to get to its most sensitive exposure for us. So I was hoping to be able to show you this in the same pretty colors that Frank had the Veil Nebula in. It would be greenish towards the center and reddish around the edges of it. And those colors are because this very thin gas, this very thin nebula of gas, is glowing from that radiation from that star. So it's fluorescing, basically, like the phosphorus in a fluorescent tube. And so it only actually gives off light in a couple of wavelengths where that gas glows. So in a color picture, it can be quite colorful. Does Frank have another object found?
I think so. Frank, can you unmute? I'm going to spotlight you.
Unmute. Am I unmuted?
Yeah, you're unmuted.
Okay. Yes, hold on. I do have, let me get to my, trying to wade through all of these screens here. Hold on. Okay. I am going to go to gallery. I'm going to add something here. Hold on. I'm going to go there, and you want the Ring Nebula. Open. Okay, and there you go. And that should, is it on the screen?
Yeah.
Okay.
So I'll toggle in between. I'll toggle back and forth to you and Drew. So that's what Drew is talking about, that the center is green and the outer edge is red. So these are the two views of the same object.
Yes. I
don't know if I can do. Let me see if this side by side. Give me just a few seconds for Facebook to catch up.
That's true. I can freeze this too.
Yeah, so Facebook's showing these side by side now.
Again, same object, two different cameras and two different telescopes. So you can see that basically with his setup, Frank is getting a little bit more magnification than we're getting with this setup, but they're close to each other. So when you have a black and white camera, you can actually get a little higher resolution. When you have a color camera, of course, you get color. So there are benefits to either effect.
This is actually a black and white image. This is, through hydrogen alpha, sulfur 2, and oxygen 3, plus a luminance filter. And I think I may have also added ultraviolet to this one as well.
Oh, okay. So this isn't a live image. This is
no, this is not. No, this is this is a photograph I took from my file here.
Oh, okay.
Yeah.
Basically, this is what it should look like on the screen here if our other camera was working better tonight, but it's not in a good mood. So
yeah, right. I've had the same problem earlier. Yes.
So, do you have another object in?
Yeah, I'm just moved next door. I'm just happen to be at M29 in Cygnus here, which is here. I'll put that on. Hold on, back to device, and we're going to go to desktop. There we go. I've changed telescopes. I'm now using the my 132 millimeter refractor, because for clusters, I was going to try to do maybe M11. Let's see if, that should be within range now. M11 looks good through the Ritchie Criterion as well, but I think it would look better. Well, I'm going to show you one other image one other photograph before I go to live again. Let me go back to my picture file here, add this.
Drew, we have a request for M51. I don't know if you can.
I could. I can still see it, so we could do that.
Here is the Veil Nebula through. Do you guys have that on the screen?
Yes.
Yeah.
Are we off screen now, Jim? I don't want to make anybody dizzy by moving the telescope. Okay, thanks.
Okay, yeah, you're getting this image of the Veil Nebula.
Yeah, we can see that, Frank.
Yeah, this was taken with the camera we're using now, the Infinity, through a 60 millimeter viewfinder. So you don't need a big telescope. That is not live, but again, I think that's 330 second exposure. So, okay, I'll leave that on while we go back to finding something on live here.
If you can, M11, I'd be interested to see how M11 works. That's one of my favorite open clusters.
Yeah, that is always a nice one. Okay, M11.
M11 is known as the wild duck cluster, but I challenge anybody to look at that and tell me why it looks like a bunch of wild ducks.
Okay, it's on. We just have to move the dome.
Oops. Hallelujah.
So Frank is moving the dome. This Veil Nebula, this is a really, really pretty object, but it's kind of tough to see. Some of us go out to Nebraska for what's known as the Nebraska Star Party, and it's really, really dark skies, and this thing just looks amazing under dark skies, but it's pretty tough to see in the light pollution of Illinois. But it's just a really, really pretty object. It's huge too. There's 3 sections to it, and it's right off of one of the wings of Cygnus.
Okay,
Frank, we got a request that if you move the scope again, could you leave it on the dome camera so they can see your scope move around?
Oh, well, yeah, we can do that. I'll turn the lights on. Okay. Again, this will be wide field, so
We're still seeing the veil right now.
I know you are. Yeah, we do things in secret here. Okay. Okay. I'm going to start the exposure here, so we'll build up a nice image. And SD max peak. Okay. All right. I'm making. I'll do a couple. I'll do an exposure too to get a nice image built up before we. Okay. Here we go. We're going to go to first desktop. There we go. Okay. I can actually zoom in a little more on that. Hold on. How's that?
Yeah, it looks nice.
Hmm?
It looks good.
Yeah. Now with the 10-inch, I'd have just about this area, but then you couldn't appreciate the fact that it's, you know, floating in space.
Yeah. So Frank, can you explain why this is called an open cluster as opposed to a globular cluster?
Yeah, this is about almost a globular. It looks like it, doesn't it? But this is a cluster which is a loose grouping of stars. Excuse me. I should have gotten a glass of water for him. Anyway, this group of stars, they're all part of the same cloud of gas which condensed into a group of stars, but they're probably, you know, many light years apart. In a globular cluster, some of those stars are a light year apart, maybe even less. They're very close together. These will gradually drift apart over the next, you know, few 100 million years, and this will dissipate in time. Globular clusters, as far as I know, generally do not dissipate unless they're ripped apart by, you know, coming near a black hole, perhaps. So these are all brothers in arms, but they will eventually dissipate. And now I'm not sure since I haven't done any research on this particular cluster. Do you know, Drew, how old this is? This is probably, given that it's a pretty dense cluster, I would guess it's pretty young. I
would have to look that up, Frank. So
yeah, but I would guess it's pretty young since it's so condensed compared to some of the other clusters we've seen. But yeah, this is it was called the Wild Duck Cluster by, I think it was Admiral Webb back in the 1880s. I think it was. For some reason, it resembled a flock of ducks, and I guess you could sort of say that, being that it has this, look at it this way, a flock of ducks going in that direction. Well, maybe, you know, I don't know.
I guess it's that star.
Well, so the Wild Duck Cluster is 316 million years old.
Yeah,
Estimated.
old ducks. Anyway, yeah, well, that is one of my favorite open clusters too.
It's a pretty cluster to find in the sky. It's right along the edge of the Milky Way.
Mm-hmm. Yeah, you can see. I mean, we're now with. I'm not sure. Let's see how. I am going to go back to. We'll leave this on the screen. I'm going to zoom in on my star chart here, and I want to see how faint the stars we're looking at tonight.
That star there, it just looks way brighter.
Huh?
Drew's talking to Tony. I just muted him.
Yeah, I am guessing we're probably looking at least 15th, 16th magnitude here. Yeah. Well, who else is in the neighborhood? Let's see. I'll zoom out. Oh, well, yeah, we're right near all kinds of cool things here. Now, I recently photographed the Pillars of Creation in M16, and that's right nearby. Shall we move there?
Sure. And while you're doing that, I'll flip over to Drew. Drew has
Okay.
a whirlpool cluster.
Muted. There, now we're not muted. We were asked for a request for M51, the Whirlpool Galaxy. This is something we did in the last 2 sessions we had out here, but it's still a great object to look at. So this is a whole separate galaxy. Everything we've looked at tonight so far has been within or part of our Milky Way galaxy. This is a whole separate galaxy. We're, again, this is called M51 or NGC 5194. It's in the constellation of Canis Venatici, which is the hunting dogs of Boötes, the herdsman, who's the next constellation over. It's commonly called the Whirlpool Galaxy. You can kind of tell why because of the wonderful spiral shape of it. It's probably close to 30 million light years away from us. It has a smaller companion galaxy, so
25 million light years away, and it's actually
you can debate that. The most recent study I showed pushed it really close to 30 million light. Oh, are we breaking up?
no. Anything on the internet is true. You can't debate.
Oh, okay. Actually, it's an interesting thing to research because you would think that this big and relatively close a galaxy, astronomers would have a really good figure for it, but you will see it listed anywhere from 15 million to 30 million light years away, and that seems kind of absurd. A lot of time, I think Wikipedia probably says 20, but there was a better paper done more recently that pushes it closer to 30 million light years away from us. So it's really hard to tell how far away things are in space. So my figure is close to 30. Anyway, so it has this classic spiral galaxy shape. This is very flat, so we're looking almost straight down on it here. If you turned it sideways, we would see it as a little thin line. The arms are not as bright as the nucleus is. The nucleus is just a denser area of stars, so that's much brighter. This galaxy has a companion galaxy. So this is a more of a dwarf galaxy, which is interacting with it. Gravity works in space. It's what holds the galaxy together. And if there are multiple galaxies around, they can be attracted to each other. This little guy and this one have obviously run into each other some because there's this arm of the main galaxy connects all the way up to the halo of the small galaxy next to it. So this is probably passed by here. It'll probably orbit back in and end up within hundreds of millions of years, pretty much being absorbed into the main galaxy itself. So it's an interesting object. It's also an incredibly beautiful object. This is one of the objects that early on when we set up this video set up here in Naperville kind of blew me away, because if you had come out here to join us, say in the 1970s or the 1980s, we were out here then, we could have showed you this in a visual telescope, and you would have seen these spiral arms. The light pollution has gotten so bad here, the brightness in the sky from the poorly aimed, poorly used lights that we have on the ground here that are shining up in the sky instead of down where they belong, has brightened the sky so much that even in our big telescope in the building next door, you basically see a little glow of the nucleus of this one next to the little glow of the nucleus of that one, and the arms are washed out by the sky glow because the sky is brighter than they are. But with the video set up, even though this is live, we can cheat and darken the sky up kind of artificially, and then take the little bit of light that's left, and just by using contrast, bring that out and magnify it out. So we can come back to seeing these arms connecting the galaxies back together again here. So this is why we built the video telescope. It wasn't us being prescient that someday there was going to be a pandemic and we would have to do everything remotely. So that if when things get better and you can come out and visit us, you will be able to look at things, at least the brighter things, well, through our visual telescope, and then also see the output from our video setup like this. If Frank has something else, or unless there are any other questions or something, we can switch over back to him.
Yeah, well, here we can, there we go. We have, that is the dome camera. I can move the telescope if you, well, actually I don't want to move, I'm taking an exposure right now, but let me get that exposure going. I've gone to M16, and it's slowly building up. So, but let's actually go to that now. I'm going to try to flip-flop all my things here. We're going to go to desktop, and okay. It's slowly building up. I'm going to increase the contrast here, and you should pick it up. There we go. Here we have, you can sort of see it vaguely. I'll zoom it in. There are the pillars of creation. They're sort of grainy right now. And I can even make it more grainy and more obnoxious, but that's too obnoxious. We'll leave it in medium. So anyway, that is, now this is, through a telescope, you can see this, you know, visually. Nebula filter helps, obviously. It's low in the south, which doesn't help either since it's in the murk down there. But this is also a very nice object for summer evenings, and right in the Milky Way.
So Frank, I'm gonna show people kind of the NASA picture of this, because I'm sure people have seen it before.
Absolutely. They can see what it should look like. Yes.
This is
There you go.
a famous image that probably most people have seen, and this is off NASA's website.
And you can see those three individual pieces there, and then when you go back to mine, you can see those same things. They're at an angle, in mine at about a 45-degree angle. Here, actually, yeah, here's 1, 2, and 3 right there. Here, right? Yeah, here, 1, 2, 3.
Yeah.
So yes, you can see the pillars of creation.
And the NASA image has had massive processing done to it to make it look that pretty.
And of course, they use their own palette. Again, of course, that's in black and white. They use, you know, filters. This is the quote unquote real color, which is the glowing red of hydrogen, H2 regions. And you will not, again, for those who are watching, you're not going to see the color through the telescope. You're going to see it, you know, it's going to be gray. But, and if you use a filter, it may be some other color. But you at least will see it, which is, you know, sort of cool to actually see something that the Hubble's telescope photographed. It's something you can sort of stare at for several minutes and really appreciate.
And of course, it's called the Eagle Nebula because it's kind of
shaped
a little bit like an eagle with its wings spread out. I mean, things get names that don't necessarily look, you know, like it. You got to use a lot of imagination to see. To see the thing that things are named after.
Well, I'll freeze this because I say it's not going to get much better. There's several other things nearby here. Let me see what we got. I mean, let's zoom in here. We have,
we are coming up on an hour. I don't know how much longer we want.
Yeah, just say when we have to go. There's M20. That's a possible. Let's see.
Looks like
We can try M20, and then if you want to, abandon ship after that, that'll be fine. How's that?
okay. So Drew's coming up on one. Do you want to show your scope slew?
Okay, fine. Yes. I'll find M20. So hold on. I will go to the. Canon camera. Okay, here we go. And now we're going to go to, find and execute. Didn't move far, but you saw it move, I assume.
Yes, yeah.
Okay, all right.
All right.
Now,
I'm going to flip to Drew's view while you're
okay.
when you're
Fine.
getting prepped. So Drew, we're back to you. What do you have there? You guys are on mute. There you go.
Are we unmuted? Okay, now we're unmuted. Thank you. We are back to an object that was on the observing list for this evening. It's another, see if people can remember what these are called, these balls of stars. These globular clusters. And this one is actually quite close to the first one that I showed. I showed M13 in, oops, telescope just jiggled a little there, sorry. Yeah, don't run into it, Tony.
Not me.
M13 in the Hercules. This is M92, also in Hercules. It's another ball of stars. Again, there's at least 300,000 stars in this cluster. If you'll remember, M13 on the screen looked maybe this big. It was bigger. This looks smaller. The reason it looks smaller is it's farther away. So M13 was about 22,000 light years away. This is about around 27,000 light years away. So it ends up in the sky looking smaller for us, just because when you get farther away from things, they look smaller. Again, a lot of stars that are very old. Some of the stars in here are close to 14 billion years old. So because new stars have been formed in these clusters since the cluster really formed while our galaxy was initially forming. So there are about 200 of these in orbit around our galaxy that we spotted using telescopes in both hemispheres. And we've seen them around other galaxies too. We can look at the Andromeda galaxy and see the globular clusters floating around it, and also a couple of other relatively nearby galaxies. So they are an artifact of spiral galaxy formation that we see around the place. Yeah, so again, and the size of this across is more than a light year across. To look this big in the sky for us at this sort of distance. Yeah, the telescope is bouncing a little bit. So this camera, unlike Frank's, which was taking exposures and the computer is combining them together into pictures, this is a live video feed, but what we have going on here is we've slowed the camera way down. So a normal video camera will send you a whole series of flickering pictures, anywhere from 24 to 30 times a second. The picture changes. We've slowed down this video chip. So right at the moment, I've got it taking exposure for 6 seconds and then sending it along. So if the telescope jiggles a little bit, or if I move it a little bit, let's see if I move it up a little bit, you won't see the change for a moment, and then there'll be a blurred image. It's smearing there a little bit because I moved it during that 6 second exposure, and now it's stopped, and then when it refreshes again, it'll be fairly still, although it's still shaking just a little bit there. This is how this setup works. It's much simpler than Frank's going through a computer thing. There are no computers here doing this. So is Frank ready for his last object?
M20.
Yeah.
Okay.
Here's beautiful M20 in Sagittarius.
So this is gas clouds around stars, and the stars are making the gas clouds glow. But in this case, the gas clouds, it didn't blow off the stars. These are the gas clouds that the stars have formed out of. So the remainders of those clouds. We see star forming regions like this. He's looking toward the center of our galaxy, into the next spiral arm in from us, looking towards the center and into a region where there's a lot of clouds of gas that haven't formed into stars yet. So we see these pockets where that cloud is lit up by new stars, or relatively new stars that are glowing at it. The reddish glow of the one side of the nebula is the hydrogen gas in that cloud actually glowing from the energy from the stars shining on it. The bluish cloud on the left side is actually just reflected light off of the dust in the gas clouds there. So another pretty kind of nebula. Anything in space that people used to look at through a telescope and see as a hazy glow got called a nebula. But when telescopes got better and techniques got better of studying things, astronomers realized that there's a lot of different things that make hazy glows. So whole galaxies used to just be called nebulas because it wasn't realized that what a separate galaxy was. They just looked like a fuzzy thing. This is a nebula that's a gas cloud where stars are forming. When we looked at the planetary nebulas like the Ring Nebula and the Veil Nebula earlier on, those are gas clouds around stars that are dying. So there's different things that can make clouds in space. Nebula just means cloud. So that's what we're looking at here. Sounds like it's time for us to close for this evening. I apologize for some of our technical glitches, but I was happy that we can bring you some images of different things. And do follow us on Facebook. Do well, look at our club website calendar for our regular programs, because we're streaming our 2 monthly programs now online. We have been for some time. And on our website, we have archived all of the videos we've made so far. So if you go to naperastro.org, or if you can't remember that, although you're probably on our Facebook page, and I'm sure there's a link there to our homepage, but you could always just use your favorite search engine and search for the words Naperville and astronomy, and we'll be at the top of the list. And you can look at our other videos, and I hope that you join us down the road for more streaming nights like this, and eventually in person when we're doing live public events again. Thanks a lot.